Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Rizqullah, and in this video, I want to explain to you all about Module 15 about IP static routing. So, why do we should learn this module? Because there are so many different ways to dynamically root a packet that you might wonder why anybody would take the time to manually configure a static root. It is kinda like hand washing all of your clothes when you have a perfectly good washing machine, but you know that some clothing item cannot go into the washing machine. Some items benefit from being washed by hand. There's a similarity in networking. As it turns out, there are many situations where manually configure a static router is your best option. There are different kind of static routes, and each is perfect for solving or avoiding a specific type of network problem. Many networks use both dynamic and static routing, so network administrators need to know how to configure, verify, and troubleshoot static routes. You are taking this course because we are taking this course because we want to become a network administrator, or we want to improve our existing network administrator skills. You'll be glad you took this model because we will use these skills frequently, and because this model is configuring static routes, there are several syntax checker activities followed by packet tracers and a lab where you can hone your skills. Okay, let's continue. Okay, so the first is 15.1 static routes. So static routes are commonly implemented on a network. This is true even when there is a dynamic routing protocol configured. For instance, an organization could configure a default static route to service provider and advertise this route to other corporate routers using dynamic routing protocol. So static routes can be configured for IP version 4 and IP version 6. Both protocol support the following types of static routes, which is the first is standard static route, and then default static route, floating static route, and then the last is summary static route. Static routes are configured using the IP route and IP version 6 route global configuration commands. So the first is next hop option. When configuring a static route, the next hop can be identified by an IP address, exit interface, or both. How the destination is specified creates one of the three following types of static routes. The first is next hop route, and then the second is directly connected to static route, and then the last is fully specified static route. So the first is only the next hop IP address is specified, and then the second is only the router exit interface is specified, and then the last is the next hop IP address and the exit interface are specified. Okay, we continue. So IP version 4 static root command, the IP version 4 static routes are configuring using this global configuration command, which is IP root network address and then subnet, and then we input the IP address and then the exit interface, and then um, we put the IP address and then the distance. Okay, so either the IP address or exit interface or the IP address and exit interface parameters must be configured. Okay, so we can choose either the IP address or exit interface or both the IP address and exit interface parameters that we can configure. Okay, so network address identifies the destination IP version 4 network address of the remote network to add to the routing table. And then the subnet identifies the subnet mask for of the remote network. And then IP address, which is this one, is identifies the next hop router's IP version 4 address and typically used with a broadcast network could create a recursive static route where the router performs an additional lookup to find the exit interface. And then the exit interface identifies the exit interface to forward the packets and then creates a directly connected static route. The last is typically used in a point-to-point configuration. And then we have the exit interface and we have both exit interface and IP address, which just creates a fully specified static routes because it specifies the exit interface and then the next hop IP version 4 address. Okay. And the distance is optional command that can be used to assign an administrative distance value between 1 and 255. Then typically used to configure a floating static route by setting an administrative distance that is higher than a dynamically learned route. Okay, IP version 6 static route command. So the command sorry the command that we learn above is for IP version 4 and then this command is for IP version 6. Okay. So in IP version 6, we add IP version 6 prefix or prefix length and then IP version 6 address and then exit interface and sorry IP version 6 address and both of exit interfaces and IP version 6 address. And then we have distance. Okay. So most of the parameters are identical to the IP version 4 version command of the command. The table shows the various of IP version 6 root command parameters and their description. Okay, so here are the table of description about the command above. Okay, so the first is IP version 6 prefix, which is identifies the destination IP version 6 network address of the remote network to add to the routing table. And then the second is identifies the prefix length of the network, the remote network. And then we have IP version 6 address identifies the next hop router IP version 6 address, typically used with a broadcast network also. And then could create a recursive static route where the router performs an additional lookup to find the exit interface. Okay, so most of it is the same. Okay, and then we have exit interface, which is identifies the exit interface to forward the packets and create a directly connected static route, typically used in a point-to-point configuration also. And then we have the both exit interface and IP address, IP version 6 address, which is create a fully specified static route because it specifies the exit interface and next hop IP version 6 address. Okay, sorry. Okay, and we have distance also, which is optional command that can be used to assign an administrative distance between 1 and 255, and we typically use to configure the floating static route also by setting an administrative distance that is higher than the dynamically learned route. Okay, there is no IP version 6. Unicast routing global configuration must be configured to enable the router to forward IP version 6 packets. Okay, so there is a note for the IP version 6 Unicast routing global configuration command. It must be configured to enable the router to forward IP version 6 packets. Okay, and then we have dual stack topology, which is, I guess, both IP version 6, both IP version 4 and 6 static root command, I guess. Okay. Currently, no static roots are configured for either IP version 4 or IP version 6. Okay. So, just a minute. Okay. So, so sorry, dual stack. Okay. So in this topology, which is uh, where we see now, there are no both IP version 4 or IP version 6 configuration in this topology. And IP version 4, okay, we move on. IP version 4 starting routing tables. Router 1, sorry. Okay, so this table shows the IP route and begin gateway for each router. So as we can see, um the IP address of 172.16.2.0 is directly connected with interfaces serial 0/1/0, and wait. Okay. Oh, I see. So, okay. So this table shows the routes for each router 1, router 2, and router 3. And we can see that router 1 can ping to router 2. None of the routers have knowledge of any network beyond the directly connected interface. This means each router can only reach directly connected network as demonstrated in the following ping test. And then router 1 cannot ping router 3 LAN. However, a ping from router 1 to the router 3 LAN should fail because router 1 does not have an entry and its routing table for the router 3 LAN. Okay, so because they don't really have that IP version 4 and IP version 6 static root, so it only can ping test to directly connected networks. Okay, sorry. Okay, we continue. So as I mentioned earlier, because the click each button to see. Okay, so we can see that each router have different directly connected network, which is the router 1 is directly connected to, I'm sorry, yeah, the router 1 is actually directly connected to router 2, and then the router 2 is directly connected to router 3, and router 3 is directly connected to router 2. And we can see that router 1 can ping to router 2 because they both of them are, sorry, both the router 1 and router 2 are directly connected, and then the router 1 cannot ping to router 3 because does not have any entry and it's in its routing table for the router 3 LAN network. So any other networks that outside the directly connected between router 1 is cannot ping or forward any packets to to outside of its network. So yeah. That is for IP version 4 starting routing tables. Okay, so for IP version 6 starting routing tables, we have okay, it's kind of like the same with IP version 4. The difference is the router sorry IP version 6 is using this, you know, this address, and it's kind of like the same as IP version 4. The router 1 can ping to router 2, and the router 1 cannot ping to router 3 because router 1 does not have N3 in its routing table for that network. Okay, we continue to 15.2, which is configure IP static routes. So IP version 4 next hop static route. The commands to configure standard static routes varies slightly between IP version 4 and IP version 6. This topic how shows us how to configure standard next hop directly connected and full specify static routes for both IP version 4 and IP version 6. In the next hop static routes, only the next hop IP address is specified. The exit interface is derived from the next hop. For example, 3 next hop IP version 4 static routes are configured on router 1 using the IP address of the next hop, router 2. Okay, so the command to configure router 1 with IP version 4 static routes to the 3 remote networks are as follows. So we add the so we add the switch above router 2, as we can see, IP route 100 172.16.1.0, which is this one, and then we add the address of router 3, which is 192.168.1.0/24, and then we add the network address for connection router 1 and router 2, which is 172.16.2.0/24. Okay. The routing table for router 1 has now routes to the 3 remote IP version 4 networks. So I guess after this we can ping from router 1 to router 3, I guess. Okay. So next we have IP version 6 next hop static routes. We're just gonna see here. Yeah. So as we can see here, there are the switch, which is 172.16.1 via 172.16.2.2. Okay, which is this address is directly connected to from router 1 to router 2. Okay, so the switch is connected via router 2. Okay, and then we have the router 3, which is which is connected via the same as the switch from the router 2, which is 172.16.2.2. And okay, we continue. IP version 6 next hop static routes. The command to configure router 1 with the IP version 6 static routes to the 3 remote networks are as follows, and it is the same as the IP version 4 next hop static routes, but the difference is that the address of the network. Okay, so okay, we're just gonna continue. So IP version 4 directly connected static routes. When configuring a static route, another option is to use the exit interface to specify the next hop address. The figure shows the topology again, which is the same topology as we see before. And 3 directly connected IP version 4 static routes are configured on router 1 using exit interface. Okay, so the difference is that the next hop is that we use the sorry okay, we use the address of the router 2 at the end of the command, and in the directly connected static root we use the interface in the end of the command. Okay, so we can see here that it's directly connected but with serial. The serial is from the router 2 actually. And then IP version 6, assuming it's the same as the above, we use this serial also, as we can see here, the serial of the router 2. Okay, and then we continue to IP version 4, fully specified static roots. And the fully specified static roots, both the exit interface and the next hop IP address are specified. This form of static root is used when the exit interface is a multi-access interface and it's unnecessary to explicitly identify the next hop. Next hop must be directly connected to the specified exit interface using an exit interface optional. However, it is necessary to use a next hop address. Suppose that the network link between router 1 and router 2 is Ethernet link, and the gigabit Ethernet 0/0/1 interface of router 1 is connected to that network as shown in the figure. Okay. Okay. So the difference between an Ethernet multi-access network and a point-to-point serial network is that a point-to-point serial network has only one other device on that network, the router at the other end of the link. With Ethernet network, there may be many different devices sharing the same multi-access network, including houses and even multiple routers. It is recommended that when the exit interface is an Ethernet network, that the static root includes a next hop address. You can also fully specify static roots that includes both the exit interface and the next hop address. Okay, so here we have the fully specify, which is we have the sorry okay, so we have the exit interface and the next hop. So as we can see here, the exit interface is gigabit Ethernet, and then the next hop is the router 2 network address, IP address, sorry. Okay. Okay. When forwarding the packets to router 2, the exit interface is gigabit Ethernet, yes, and the next hop is as shown in the figure. Okay. As before, IP version 6 fully specified static root. I'm assuming it's kind of like the same, but the difference is on the IP address. In a fully specified IP version 6 static root, both the exit interface and the next hop IP version 6 address are specified. There is a situation in IP version 6 when a fully specified static root must be used. If the IP version 6 static roots uses an IP version 6 link local address as the next hop address, use a fully specified static root. The figure shows an example of a fully specified IP version 6 static root using an IP version 6 link local address as the next hop address. Okay, so okay, I guess it's kinda like sorry. I guess it's kinda like different. So okay. So um we have discussed the IP version 4 before the IP version 6 as we discussed here. So the difference is that not just the address. So for IP version 6, they use the IP version 6 link local addresses, and on the IP version 4, we use the address of the router 2. I guess it's kind of slightly different from the IP version 4. So here we can see that the local addresses of the IP version 6 is a bit different. Yeah. So as we wait, it has to be. Oh yeah. So we we have to use serial again, not just the link local addresses. As you can see, has to specify for link local next hop. So in the example, a fully specified static route is used using the link local addresses of router 2 as the next hop addresses. Notice that iOS requires that an exit interface be specified. Yeah. So we cannot really just use the link local addresses of IP version 6. We must specify the exit interface for it. The reason a fully specified static route must be used is because IP version 6 link local addresses are not contained in the IP version 6 routing table. Link local addresses are only unique on a given link or network. The next hop link local addresses may be a valid address on multiple networks connected to the router. Therefore, it is necessary that the exit interface can be included. The following example shows the IP version 6 routing table entry for this route. Notice that both the next hop link local addresses and the exit interfaces are included. Oh, I see, I see. So we have the next hop link local addresses, and then we have the exit interfaces that are included, because as we speak before that as we speak earlier, that the exit interfaces must be specified because the link local addresses are not contained in the IP version 6 routing table. Okay. Okay, verify static route. Along with show IP route, show IP version 6 route, ping and trace route, trace route. Other useful commands to verify static routes include the following: show IP route static, show IP route network, and then show running config section IP route. Replace IP with IP version 6 for the IP version 6 versions of the command. Reference the figure when reviewing the command example. Okay. So here we just display only IP versions for static routes. We use this show IP route static and then begin gateway, and then we have a display a specify IP version for network. Okay, for the specify one, we must type the IP address that we want to see the route. Okay, I'm sorry. We must type the IP address. We must type the IP address if we want to see the root of it. It's like this, show IP root, and then we type the IP address, and then display the IP version 4 static root configuration. So here that we can see what configuration are running, and for the section IP root is that we use this to kind of like choose which show running config that we want to see, and we want to see the section IP root. Okay. Okay, we continue. Show IP version 6 root static. So here is for the IP version 6, and it's only display the static root, and we have the specify one, and it's kind of like the same. We must type the address that we want to see specifically, and then the last is we can see the running config for selected section, which is IP version 6 root. Okay, we continue. Okay, this is a syntax checker. So configure static roots based on the specified requirements. Okay, I guess this is the directly connected static roots. I guess we must add. Oh, yeah, we must. Sorry, sir. We're just gonna show all, and we can see. Yep, it's kind of like the same. So for the here, the first list is for. Wait. Oh, this is the router 2 actually. Okay. So wait, wait a minute. Oh, so here is the router 2 that want to create a route for. Wait, wait a minute. Yeah, this is the router 2 trying to make a route to router 3, and then here are the IP route from where? Wait, 3? There are no 3 here. Wait. Oh, so this is the configure for IP version 6 next hop static root on router 2 to this. Yes. Oh yeah, I can see. Okay, so this is the route from router 2 to router 1, and then we have the IP version 6 version for configuring a directly connected static routes from. I guess this one is from router 2 also to wait. Oh yeah, this is from router 2 to router 3, and then this is from router 2 to router 1. And we can verify it with show IP route static. Or okay, so this one is verified the IP version 4.1, and then we have the IP version 6 type, which is show IP version 6 root static, and then as we can see here that we now we use the router 3, we create an IP route to router 2. Yes, to router 2, which is we can see this serial here, and then oh no, I'm sorry. So we create a route to router 1 using the serial of router 2 connection, and we can see that here we use the sorry, we make a route to switch above the router 2 using router 2 serial interface, and then um yeah, the last one is from router 3 want to make the route to router 1 using router 2 serial exit interfaces. Okay, so and then the after that we have the version of IP version 6 root. Okay, and this is only the kind of like we want to verify the root in the router 3. We use show IP root static, and then we use show IP version 6 root static. Okay, um that is all what I can explain about configuring an IP static roots from sorry, configuring IP static routes of IP version 4 and IP version 6. And I hope you guys understand the explanation I gave you, and see you in the next video. I'm sorry. The next module will be explained from my friend, and I hope you guys understand it. Thank you for watching. Signing out.
Baik, di sini saya Setiawan, saya ingin menjelaskan di modul 15 yang judulnya static routing. Di sini configure default static router. Jadi default static route. This is topic show you how to configure a default route for IP versi 4 and IP versi 6. It also explain situation in which a default route is a good nice. A default route static that match all packet install of the storing router for all the network in the internet. Router commonly use that either configure local or from another router. Jadi root status default. Topik ini mengonfigurasi root default untuk IP versi 4 dan IP versi 6. Topik ini juga menjelaskan situasi di mana root itu merupakan pilihan yang baik. Root default adalah root yang cocok untuk paket alih menyimpan root semua di jaringan internet. Router biasanya menggunakan rute default yang dikonfigurasi secara lokal, dipelajari dari router lain. Root status default umumnya digunakan saat menghubungkan router ke jaringan penyedia layanan atau router rintisan, router dengan hanya satu router terdahulu. Seperti contoh di bawah ini, root static default IP versi 4. Sintaks untuk root default IP versi 4 dan rute static IP versi 4 lainnya. Catatannya, rules static IP versi 4 umumnya disebut dengan root what zero. Sintaks perintah untuk status default IP versi 4. Seperti contoh di bawah ini. Nah, di sini adalah rute status IP versi 6-nya. Lanjut, ada mengonfigurasi rute status default. Pada gambar R1 itu mengonfigurasi dengan 3 rute status. Satu untuk menjangkau masing-masing jaringan jarak jauh dalam topologi. Contoh, namun R1 adalah rintisan hanya terhubung ke R2. Oleh karena itu, akan lebih efisien mengonfigurasi satu rute status default. Nah, ini adalah contoh IP versi 4 dikonfigurasi dengan router 1 dengan mengonfigurasi yang ditunjukkan oleh contoh yang tidak cocok entry rute yang lebih spesifik. Nah, dia akan meneruskan ke R2 atau router 2. Jadi di sini rute status IP versi 6 dikonfigurasi dengan yang sama. Dengan konfigurasi ini, apapun yang tidak cocok dengan entry IP versi 6, dia akan lebih spesifik diteruskan ke R2. Lanjut, ada verifikasi rute status default. Verifikasi rute default IP versi 4. Output show IP route static itu adalah menampilkan root dalam tabel routing. Kita bisa perhatikan di bagian bintang di samping rute seperti kode S itu menampilkan bahwa kode output show IP route itu akan menunjukkan rute status ini akan lebih default kandidatnya menjadi lebih rute sebagai gateway last of the resort. Nah, di sini ada contohnya. Di sini ada verifikasi status default IP versi 6. Ada contohnya show IP versi 6 static untuk menampilkan tabel routing. Nah, kita bisa perhatikan konfigurasi root yang menggunakan topeng /0 untuk default IP versi 4 awalan titik 2/0 itu rute default IP versi 6. bahwa topeng subnet awalan IP versi 6 itu peruturan yang menentukan banyak bit yang harus cocok antara alamat IP, tujuan, paket, dan dalam tabel peruturan. Lanjut, ada pemeriksa sintaks rute statis default. Lanjut, ada floating static routes. As with the seperti topik di modul ini adalah mempelajari cara mengonfigurasi statis mengambang IP versi 4 dan IP versi 6 dan kapan menggunakannya. Jenis rute statis lainnya adalah rute statis mengambang. Rute statis mengambang adalah yang digunakan untuk menyediakan jalur cadangan ke rute dinamis utama. Misalnya, asumsikan bahwa seorang administrator membuat rute statis mengambang sebagai cadangan untuk rute yang dipelajari EIRP. Secara default, rute memiliki jarak administratif 1, sehingga lebih disukai dipelajari oleh peruteran dinamis. Misalnya, jarak administratif beberapa protokol dinamis, gateway interior umum. Yang utamanya ada EIGLP 90, OSPF 110, dan ISS 115. Jarak rute dapat ditingkatkan membuat rute diminati dibandingkan rute lain yang dipelajari oleh peruteran dinamis. Lanjut, ada mengonfigurasi mengambang IP versi 4 dan IP versi 6. Rute statis IP mengambang dikonfigurasi dengan menggunakan argumen jarak untuk menentukan jarak administratif jika ada jarak administratif yang dikonfigurasikan. Bisa kita lihat pada topologi ini ada IP rute dan IP versi 6 root yang dikeluarkan pada router 1. Rute defaultnya dipilih dari router 1 ke router 2. Koneksi router 3 digunakan untuk cadangan saja. Di sini ada perintah-perintahnya. Di situ sudah jelas perintahnya. Jadi lanjut, pemeriksa sintaks konfigurasi router statis mengambang. Nah, di sini kita mengonfigurasi berdasarkan persyaratan yang ditentukan. Baik, terima kasih. Itu saja yang bisa disampaikan. Selanjutnya akan dijelaskan oleh teman saya.
Baiklah, selanjutnya saya Amanah Bulan Naila akan menjelaskan modul 15.5 Configure Static Host Routes atau pada 15.51 Host Routes. This topic show you how to configure IP4 and IP6 static host route and when to use them. Jadi topik ini bagaimana untuk mengkonfigurasi IP4 dan IP6 static host route dan bagaimana untuk menggunakan mereka. Nah, untuk IP4 itu memiliki host rutenya 32 bit, sedangkan IP6 itu 128 bit. Kemudian rute host yang terinstall secara otomatis. Jadi Kisco secara otomatis memasang rute host yang dikenal sebagai rute host lokal. Saat alamat interface dikonfigurasi pada router, rute host memungkinkan proses yang lebih efisien untuk paket yang diarahkan ke router itu sendiri. Yang artinya itu merupakan tambahan rute yang terhubung yang ditandai dengan C dalam tabel peruteran untuk alamat jaringan interface. Jika interface aktif pada router dikonfigurasi dengan alamat IP, rute host lokal secara otomatis ditambahkan ke tabel routing. Rute lokal ditandai dengan L dalam output tabel routing. Next, rute static host. Jadi rute host dapat berupa rute statis yang dikonfigurasi secara manual untuk mengarahkan lalu lintas perangkat tujuan tertentu. seperti server yang ditunjukkan pada gambar ini. Rute statis menggunakan alamat IP tujuan dan subnet mask 255.255.255.255/32 untuk rute host IP 4 dan prefix lainnya /128 untuk rute host IP 6. Next, mengonfigurasi rute host static. Jadi untuk mengonfigurasi rute host static IP 4 dan IP 6 pada router cabang untuk mengakses server dapat menggunakan command seperti ini. IP root, kemudian masukin IP-nya dan IP 6, sedangkan untuk IP 6 root seperti ini dan exit. Selanjutnya memverifikasi rute host statis. Jadi pada bagian ini itu untuk meninjau atau memverifikasi bahwa rute IP 4 dan IP 6 pada tabel itu aktif dengan menggunakan komen seperti ini. Next, untuk mengonfigurasikan rute host static. IP 6 dengan link lokal next hop untuk rute static IP 6. Alamat hop berikutnya dapat berupa alamat link lokal dari router yang berdekatan. Namun, kita harus menentukan jenis interface dan nomor interface saat menggunakan alamat link lokal sebagai hop berikutnya. Nah, seperti yang ditunjukkan pada contoh ini, pertama rute host statis IP 6 yang asli dihapus, lalu rute yang ditentukan sepenuhnya dikonfigurasi dengan alamat IP 6 server dan alamat link lokal IP 6 dari router ISP. Nah, di sini ada syntax checker. Nah, seperti ini. Selanjutnya pada 1563, apa yang saya pelajarin di modul ini? Yang pertama yaitu static routes. Jadi, static routes ini dapat dikonfigurasi untuk IP 6 dan IP 4. Nah, kedua protokol yang mendukung jenis rute statik yaitu rute statik standar dan rute static default. Kemudian, float static route dan summary static route. Static routes ini dikonfigurasikan menggunakan command root global configuration. Saat mengonfigurasi static route, hop berikutnya dapat diidentifikasi berdasarkan alamat IP interface output interface atau keduanya. Nah, sedangkan cara untuk menentukan tujuan akan menciptakan salah satu dari jenis ketiga route static ini yaitu hop berikutnya terhubung langsung dan ditentukan sepenuhnya. Static route IP 4 dikonfigurasi menggunakan command configuration global IP address seperti ini. Kemudian konfigurasi static routes IP static routes. Dalam static routes hop berikutnya, hanya alamat IP hop berikutnya yang ditentukan. Interface keluar berasal dari hop berikutnya. Saat mengonfigurasi static route, opsi lainnya adalah menggunakan interface keluar atau output interface untuk menentukan alamat hop berikutnya. Static routes yang terhubung langsung akan hanya digunakan dengan interface serial point-to-point. Dalam static routes yang ditentukan sepenuhnya, output interface dan alamat IP hop berikutnya ditentukan. Bentuk static routes ini digunakan ketika interface output interface adalah interface multi-akses dan perlu untuk mengidentifikasi hop berikutnya secara eksplisit. Hop berikutnya harus terhubung langsung ke interface output interface yang ditentukan. Dalam static routes IP 6 yang ditentukan sepenuhnya, output interface dan alamat IP 6 hop berikutnya ditentukan. Selain show IP route, show IP6 route, ping dan trace route, komen lainnya untuk memverifikasi static routes yaitu seperti show IP route static, kemudian show network static, dan yang lainnya. Kemudian configure IP default static route. Jadi untuk mengonfigurasikan rute statis default IP yaitu default route ini merupakan static routes yang cocok dengan semua paket. Rute default tidak menentukan bit paling kiri untuk mencocokkan antara rute default dan alamat IP tujuan. Static route default biasanya digunakan saat menghubungkan router edge ke jaringan penyedia layanan dan router stub. Sintaks comment sintaks untuk static route default IP4 mirip dengan route statis atau static route IP4 lainnya. Selanjutnya, configure static host routes atau konfigurasikan static routes floating. Configure floating static routes atau mengonfigurasikan static routes floating. Jadi static routes floating ini merupakan rute static routes yang digunakan untuk menyediakan jalur cadangan ke static routes atau dynamic utama jika terjadi kegagalan tautan. Floating static routes dikonfigurasikan dengan jarak administratif yang lebih tinggi daripada router utama. Secara default, static routes memiliki jarak administratif 1 yang membuatnya lebih disukai daripada rute yang dipelajari dari protokol perutuan dynamic. Jika tidak ada jarak administratif yang dikonfigurasi, nilai default yaitu 1 digunakan. Kemudian yang terakhir, configure static host routes atau konfigurasikan rute host static. Rute host adalah alamat IP4 dengan 32 bit atau alamat IP6 dengan 128 bit. Ada 3 cara rute host dapat ditambahkan dengan ke tabel perutuan. Yang pertama yaitu diinstal secara otomatis saat alamat IP dikonfigurasikan pada router. Kemudian dikonfigurasi sebagai rute static routes dikonfigurasi sebagai host static route atau diperoleh secara otomatis melalui metode lain yang tidak tercakup pada modul ini. Pada Kisco iOS, yaitu secara otomatis menginstal rute host yang dikenal sebagai rute host lokal. Jadi saat alamat interface dikonfigurasi pada router, rute host dapat berupa rute statik yang dikonfigurasi secara manual untuk mengarahkan lalu lintas ke perangkat tujuan tertentu. Untuk static routes IP6, alamat hop berikutnya dapat berupa alamat tautan lokal dari router yang berdekatan. Namun, kita harus menentukan jenis interface dan nomor interface saat menggunakan alamat lautan lokal sebagai hop berikutnya. Untuk melakukan ini, rute host statis IP6 asli dihapus. Kemudian rute yang ditentukan sepenuhnya dikonfigurasi dengan alamat IP6 server dan alamat tautan lokal IP6 dari router. Next, selanjutnya ada quiz. A network administrator configures a router by the command IP route 0.0.0.0. What is the purpose of this command? To provide a route to forward packets for which there is no route in the routing table. Number 2. Which type of static route that is configured on a router use only the exit interface directly connected static route? Question 3. Network administrator used the command IP route 172.18.0.0 serial 0/0/1 to configure a floating static route on a router. That route will function as a backup route for which the AIGRP Lineage Network 172.18.0 180.0.0/60. After this configuration, the AIGRP root is removed from the routing table even though AIGRP is still functioning properly. Why is the static root not functioning as intended? The administrative distance value is not high enough on the static root. Question 4. What type of static root is created when the next hop IP address and exit interface are specified? Fully specified static root. Question 5. What is the correct syntax of a floating static root? Question 6. Which static root statement show a recursive IP6 static root? A network administrator is configuring a route to forward packets to a specific web server. What type of route should be configured by the administrator? A host route. Next, which command would create a valid IP6 default route? What is the characteristic of a default static route? It identifies the gateway IP address to which the router sends all IP packets for which it does not have a learned or static route. Next, what is the purpose of a floating static route? It allows an alternate connection to be used when the preferred link fails. Which IP6 static route would serve as a backup route to dynamic route learned through OSPF? Next, what command or set of commands would be used to determine if the following configuration on a router high HQ works as designed? Next, which type of static route typically use the distance parameter in the route IP route global configuration command? Floating static route. Next, why would a floating static route be configured with an administrative distance that is higher than the administrative distance of a dynamic routing protocol that is running on the same router? To be used. Next, what network address and subnet mask combination will be used to create a default static route that match any IPs for destination? Oke, ini dia hasil presentasi dari kelompok kami. Kurang lebihnya saya mewakili kelompok kami memohon maaf. Saya akhiri. Wassalamualaikum warahmatullahi wabarakatuh.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Jadi pada hari ini saya akan membuatkan sebuah video simulasi ya pakai tracer. Yang dimana paket tracer kali ini baru di modul 15, yang mana kita akan mengkonfigurasi IPv4 dan IPv6 static dan default routes seperti itu. Ini ada list table-nya. Kita langsung masuk ke part 1. Ya, di part 1-nya kita langsung ke step 1. Nah, di edge router, kita konversi directly connected, ya, IPv4 default static route. This is primary default routes should be through router ESP1 seperti itu. Oke, kita langsung masuk saja ya. Kita langsung konfigurasikan Di sini kita masukkan IP root ya. 0 0 0 0 posisi 0 0 0 0. Oke. Kita masukin ya ini ya. 0 0. Dia ke ESP2. Oke. Itu cuman itu ya peringatan doang ya. Dia ke ESP2 ya. Sini. Lalu kita buat floating statiknya nih. Di sini 5 ke S001. Ya, lalu kita ke executor lagi. Lalu kita IP root lagi ya. S00. Itu dia kasih 1 di sini. Lalu kita tambahkan angka 5. Oke. Nah, sekarang kita akan konfigurasikan IPv6-nya. Sekarang kita IPv6 route di sini. Lalu 2.2.0 sorry, S0 S0 lalu kita masukkan yang ke ESP1 yaitu IP address-nya yang ini saja. 001 DB8. Oke, habis itu kita ketik 2001, habis itu titik 2 DB8, setelah itu tidur lagi, habis itu 1, seperti ini. Kita enter. Oke, sepertinya benar ya. Nah, sekarang sudah itu lakukan lagi ya. Seperti tadi. Cuman kita berubah di sini ya. Plottingnya. Di bagian sini, di bagian setelah ini kita kasih angka nomor, kasih angka 2, kita beri angka 5. Oke. Oke. Part 1 sudah. Sekarang kita masuk ke part 3. Part 1. Oh, ini part 2 ya. Part 2-nya udah ya. Part 3. Sekarang kita akan konfigurasi IP static root di internalan pada ESP1. Oke. Nah, begitu juga dengan ESP itu ya. ESP ini nanti part 4-nya. Oke. Kita close dulu, kita masuk ke ESP1. Kita buat. Oke, di sini kita sebenarnya yang mirip ya tadi sama yang ini tadi. Mungkin sorry, ini ya kita mungkin saya akan skip dulu bagian-bagian sini sama bagian sini ya directly connected-nya. Kita bagikan desain yang 5, nanti saya akan beritahu perintahnya. Oke, saya pause dulu sebentar. Oke. Di sini di ESP1 ya. Saya sudah membuat konfigurasi IP4 static root-nya yang dia ke executor. Nah, di sini kita bisa lihat ya. Ini untuk yang bagian sini. Lalu yang untuk LAN 2-nya ini. Lalu untuk ESP1-nya ini directly connected-nya kita ke sini. Lalu ini juga ya connected-nya kita di sini. Oke, sekarang yang keempat kita akan konfigurasi ESP1 untuk IPv6-nya. Oke. Seperti biasa, akan saya pause saja untuk bagian sini ya, di step 1, step 2-nya nanti akan saya beritahu di setelah itu. Oke, kita lanjut lagi. Nah, di sini ya semuanya kita sudah melakukan IP yang keempatnya kita konfigurasikan. Nah, di sini kita bisa lanjut lagi. Di sini kita sudah melakukan configure IPv6 static root-nya ya. Nah, di sini sudah kita tambahkan. Lalu yang ke sini juga sudah ke LAN 2 yang sudah kita tambahkan juga. Lalu untuk next hop configure-nya di LAN 5-nya sudah kita tambahkan juga di bagian sini. Dan yang selanjutnya juga kita sudah tambahkan di bagian sini. Seperti itu. Oke, kita lanjut ke part 5-nya, yaitu kita akan konfigurasi host route-nya di sini. Kita masuk ke edge router lagi ya. Yang pertama-tama kita akan IP route terlebih dahulu. IP route 198.0.0 0.10. Nah, habis itu kita masukkan 255 serial gitu saja 0/0/0. Oke, habis itu yang selanjutnya kita lakukan yang ini ya, dengan distance-nya 5. Oke, kita tinggal tambahkan sini 1, kita berikan dia spasi 5 di sini, dan enter. Oke, lalu kita konfigurasikan IPv6 host route-nya. Nah, ini agak ribet ya IPv6 ini, karena dia tidak pakai angka, jadi pakai huruf-huruf gitu. IP route IPv6 nih, sorry. IPv6 route. Habis itu kita ketik ya 201, habis itu titik habis itu titik 1 titik 2 titik 2 dB 8 titik 2 F titik 2 F titik 2 titik 2 titik 2 10/128. Nah, lalu kita masukkan lagi nih ya 201 terus TB8, habis itu titik A 1 titik 2 lagi 1. Sudah 93% ya di sini. Lalu sebentar. Nah, oke ya, sudah. Nah, cuman tadi saya cek ternyata masih 93%. Nah, di bagian routing 3 masih ada kesalahan. Nah, mungkin saya akan coba ulang ya, cek ulang apakah ada yang salah atau ada yang salah lewat. Mungkin akan saya post terlebih dahulu. Oke, udah saya coba ulang-ulang dan ternyata bukan ini ya. Cuman jawabannya itu adalah yang ini untuk terakhir ini. Ya, jadi ini jawabannya. Oke, itu saja yang sudah saya sampaikan untuk konfigurasi IPv4 dan IPv6 setting dan default-nya. Saya Zakon Ahmad Wijaya. Wassalamualaikum warahmatullahi wabarakatuh.